Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Today I will present you my research, which is convolutional search for image authentication on fragile watermarking. This research is my research with my supervisor, Dr. Verda Ernawan and Dr. Danakon Nincarian. The outline of this presentation would be the introduction and then the related works, the proposed method, the experimental result, and the discussion. For the introduction, the advancement of image editing software has facilitated the manipulation of the image, which may affect the integrity and authenticity of the image. For example, an altered medical image may affect the doctor's decision to treat the patient. Another example, a modified crime scene image may also influence the judge's decision in the court. Therefore, the researcher has proposed various ways to secure and maintain the integrity of digital image using image authentication technique. This technique can detect and localize the temporal region of the image. The confusion matrix is utilized to evaluate the accuracy and precision of the temporal localization. In general, image authentication are divided into two categories. The first one is the passive authentication and active authentication. Passive authentication consists of tempering specific authentication. So it means we cannot use a single algorithm to detect the tempered image using passive authentication. And then the second one, the irregularities. So the image authentication works by detecting the irregularities on the tempered image. And then in active authentication, there are two methods. The first one using digital signature, and then the second one using the watermarking. So the digital signature means zero watermarking. In the watermarking process, there are two steps, which is embedding and extraction. In the embedding stage, we can use transform domain or LSB. While in the extraction method, there are two types of authentication, which is authentication only and authentication with recovery. These are 6 related works to image authentication. From 2022, fragile watermarking scheme for temporal localization in image using logistic map and singular value decomposition. Also from the older 2021, and then 2020 and 2019. Our proposed method as follows. At first, the cover image, we will divide the cover image into 3 channels, which is red, green, and blue. And then, so we'll generate authentication bit. The authentication bit also generated based on a key. So a key is an integer which value will create a random noise. So the random noise is used as a key, and then it will be incorporated in authentication bit generation. And then when the authentication data is generated, we will embed the authentication data into the cover image, and then it will output a watermark image. The watermark image, we can send the image into communication channel or any internet connection anywhere, and then in the communication channel there may be a possible attack. So the user or someone else maybe try to attack or modify the watermark image. And then when we receive the image from the internet, we will treat the image as a tempered image. And then in the extraction process, the tempered image is divided into RGB, and then we will extract the watermark data, and then we will also reconstruct the watermark. So the reconstruction process essentially are the same as the watermark generation process here. And then we will compare between the extracted watermark and then the reconstructed watermark. So the result of the comparison will be fit into 3-layer authentication: the first layer, second layer, and the third layer. Convolutional search authentication, which is the proposed method in this paper. The output is the temper localization. So we will know which region of the image, which area of the image that already tempered. This is the second layer authentication. There are 3 steps in second layer authentication. For the first step, we will check the tempered region of the image in the adjacent pixels in the left, right, top, and bottom. And then the second B, the layer 2B, we will check the diagonal position of the tempered region. And then in layer 2C, we will check the outside layer in the top and bottom, left and right position. The experimental result of our research, at first, we will compare between the original image and the watermark image. So if we look closely, we would not find any differences between the original image and the watermark image. But if we check only the LSB, the less significant bit, we will find the delta. So it means delta only shows the difference of the LSB, least significant bit of the image. And then we can compare the watermark image quality using PSNR and SSIM. The PSNR are measured in dB or decibel. Our proposed method produced 51.14 decibel, while another method are reside below 50. In fact, most of them are 44 to 47. The second one is SSIM. It shows that our proposed method is superior compared to the existing method. The next step is watermark extraction and temper localization. In this image, I show you the watermark image and the temper image. So in the temper image, we replace the airplane image with this one. And then we will find which region of the image is already tempered. At first layer authentication, we can find this one. It shows that it performed 50% of the time. So 50% of the time the temper is detected, while another 50% of the time the temper is not detected. And then we employ the first layer and the third layer, and it produces a better result. And then we employ first layer, the third layer, and 2A. It produces a better result. In the end, if all the algorithm is implemented, then we will find a better temper localization as shown in this image. In addition, we also compare the confusion matrix between the proposed method and the existing method. It shows from the true positive rate and false negative rate, false positive rate, true negative rates. It also measures the precision and the accuracy in TPR and TNR. It shows that our proposed method can detect the temper region in 99.91%. As a result, the precision of our algorithm is 100%, while the accuracy is 99.95%. It is much better compared to the existing method. The conclusion of this research is that this paper has presented image authentication based on the fragile image watermarking technique. The authentication data was generated based on 7 MSP of each pixel. The scheme embedded the authentication data into the LSB. The scheme utilized a convolutional search to increase the detection rate. The experimental results show that the scheme could produce a high quality watermark image with the PSNR value of 51 decibel. The scheme can localize the temporal image with high accuracy and precision. It proves that superiority of the proposed scheme compared to the state-of-the-art method. Thank you.